it has to show that area of triangle AED times area of triangle BEC equals area of triangle AEB times area of triangle DEC. So let's call this, if we call this A1, call this A2, we'll call this A3, and finally we'll call this A4. So we're asked to find that the products, that's the opposite areas that are equal. If you multiply this, that is equal to this, the product of this. Okay, let's call the angle here theta. We know by vertical angle theorem this is also theta. Again, this is a straight line, so this should be 180 minus theta. Again, by vertical angle theorem, this is also 180 minus theta. So again, let's denote AE. You know this E. Let's call AE A. Why this is B? EC B. Again, DE, let's call it C. Finally, EB, let's call it D. So as you can see, we have SAS triangles here. So we find the area. So we now see that A1 is half the area, half AC sine theta. Do you remember? Area of a triangle given two sides and an included angle. That is it. Again, A2 is half BD sine theta. A3 equals half A3 half BC sine 180 minus theta. And we know in trigonometry, sine 180 minus theta is sine theta, second quadrant. So we have half BC sine theta. And finally, A4 is half AD sine 180 minus theta, which is half AD sine theta. So let's now multiply A1 times A2. A1 A2 is now half AC sine theta times half BD sine theta. Half times half is 1 over 4. We have 1 over 4 A, B, C, D sine squared theta. So again, let's do A3 times A4. We have half BC sine theta times half AD sine theta. Again, we have 1 over 4 ABCD sine squared theta. So as you can see, the two have the same results. So from here you can see that A1 times A2 is equal to A3 times A4. As far as this, you know, this is a trapezium. Multiply the two opposite areas. They are always equal to the product of the other two areas. So we've proved that. We have to find area of ABCD, that's area of the trapezium, given the following information. So we are going to use a property that is very important, that if you have a trapezium, that if you join this, that the area formed by the non-parallel sides that are equal. So if here is A, here is also A, while here B and C. So whatever that is here must be here. The area here is here. And also the product of the two areas, the opposite areas, are equal. So I'm saying that A times A squared must be equal to BC. So that's the property we are going to use here. So if we call here X, here is also X. So we now see that X squared must be equal to 5 times 15. And 5 times 15 is the same thing as 5 times 5 times 3. So we see that X is square root of 5 squared times 3, which is square root of 5 squared is 5 times root 3. So X is 5 root 3. So we're asked to find the area of ABC. We know that area of ABC is the addition of the areas. So therefore, area of ABCD is X plus 5 plus 15. And X plus X is 2X. So we have 2. X is 5 root 3. So 2 times 5 root 3 plus 20. And 2 times 5 is 10. So 10 root 3 plus 20. So our answer is option B.